that you mentioned this is a main reason for the phenomenon.
Yes, we believe that this is all shown in our simulation actually, because again, the specific rotation of single balls are not of importance in our theory, because they would not affect the overall direction of rotation or counter rotation and the holistic phenomenon.
However, I believe if the balls are packed densely, and it will have interparticle friction, and it will effectively stick to the containers and cause a counter rotation. Did you agree with the explanation?
Yes, we discussed it in the geometric frustration.
Yes, so
we believe that increased overall friction of the balls to
yes,
together
yes.
and therefore act like anti-frustration.
So the geometric frustration will let the balls know self-rotation, right?
But not without self-rotation. That is not correct. It would reduce.
Yes.
The stand.
Yes, in a dense area, it will stick to a container, to the wall of the container. And did you investigate the self-rotation in your simulation? Since you agree this is the main reason, and can you see the self-rotation in your simulation?
You want to see the?
Can you see the self-rotation in the simulation?
Here. We define angular velocity with the balls themselves.
But it's I suggest that you need to go to a three-dimensional model so that it will include the self-rotation, and it will be more appropriate to analyze the phenomenon.
Okay, thank you. But our simulation is only two-dimensional in terms of graphic processing, not in terms of the calculation. And there is still a rotation or spinning that they are present in our simulation, and they are taken into account.
Yes, but you cannot see it, and you cannot investigate it. Okay, thank you. Then, did you think that the angular velocity will be different at different parts of the cluster?
Yes.
Then how will the angular velocity be different?
The parts that have direct contact with the wall would be more stable.
And then the angular velocity will be bigger or smaller comparing to the other parts? Will be smaller.
Yes.
And I believe in the counter rotation part, the balls that contact with the wall will have a bigger have the more significant phenomenon with bigger counter rotation velocity.
Yes. We discussed.
Yeah, so it will be bigger, right?
It will have a no-slip boundary condition, or at least approaching a no-slip boundary condition.
Yeah, so the balls that contact with walls will have a bigger counter rotation velocity.
What do you mean they have a big counter rotation? What did you just say?
And it's like a